Alright, Econ 200, let's go over the Chapter 13 homework problems. I'm going to talk about 4 of the problems, well, 3 of them in this video and 1 in the next video. So in this video, I'm going to talk about under Facts and Tools, problems number 2 and 4. And under Thinking and Problem Solving, I'm going to talk about problem number 3. Thinking and Problem Solving, problem number 2 also gave people difficulty, but it will be easier for me to show you the answer to that with a spreadsheet than it will to draw anything out. And so I'm going to post a separate video for that one that allows me to capture the screen on my computer. So let's begin. Facts and Tools, problem number 2. Part A says, consider a market like the one illustrated in figure 13.5 where all firms have the same average cost curve. If a competitive firm in this market tried to set a price above the minimum point of its average cost curve, how many units would it sell? So what I've got here is basically a hand-drawn rendering of figure 13.5. You've got a competitive market on the left, a monopoly on the right. And part A is about the competitive market. So in the competitive market, you've got a supply curve that's perfectly flat. That's essentially because the firms all have exactly the same average total cost curve. And if it's like the monopoly market, it's also telling us that every firm, their marginal cost for each unit is exactly the same. So if they tried to raise their price above their average total cost curve, what would happen? Well, in a perfectly competitive market, the quantity that they sold would fall to 0 because this demand curve is not the demand curve for any particular firm. It's the demand curve for the industry as a whole. And so if you raise your price at all, there are a whole bunch of other firms that are ready to sell exactly the same thing that you're selling if you're in a competitive market. And so these buyers on this demand curve, they're not going to pay a higher price to you. They're just going to find another competitor along the supply curve and make their purchase from that competitor instead of making the purchase from you. So if you raise your price above average cost in a perfectly competitive market, you're going to lose all of your sales. It'll drop to 0. Part B, if a monopoly did the same thing, raising its price above average cost, what would happen to the number of units it sells? Does it rise, fall, or remain unchanged? Well, it's going to fall. Okay, for the monopolist, this downward sloping demand curve is the monopolist's demand curve. The firm demand curve and the market demand curve are the same thing. So because it's downward sloping, you know that a higher price is going to lead to a lower level of output. However, because there's nobody selling a perfect substitute for what this monopoly is selling, you also know that the number of units they sell isn't going to fall to 0 if they raise their price. So in this example, suppose they were setting their price equal to marginal cost, and they're selling this many units. If they raised their price, let's say to the point where marginal cost equals marginal revenue, then they would sell fewer units, but they wouldn't lose all of their trades at the same time. Part C, what accounts for the difference between your answers to parts A and B? As I've mentioned already, it has to do with the substitutes. In a perfectly competitive market, every seller along the supply curve is selling exactly the same thing, and they're willing to sell it at the market clearing price. And if any one of these sellers tries to raise their price, instantly the consumers can go somewhere else and buy exactly the same thing at a lower price than at the market clearing price, which is lower than the one odd firm setting its price high. For a monopoly, that's not the case. If you raise your price as a monopolist, yes, you're going to lose some sales, but your consumers don't have a perfect substitute. There is no second or third or 100th firm out there selling exactly what you're selling. And so their choice is either buy what you're selling or don't buy what you're selling. They can't buy what you want to sell from somebody else. Or rather, maybe another way of putting that is buy from you or just don't buy at all in that market. Okay, and so the monopolist has a downward sloping demand curve because there are no good substitutes for what it is selling. All right, Facts and Tools, problem 4. Part A, when selling ebooks, music on iTunes, and downloadable software, the marginal cost of producing and selling one more unit of output is essentially zero, which is the same thing they point out as saying marginal cost equals zero. Let's think about a monopoly in this kind of market. If the monopolist is doing its best to maximize profits, what will marginal revenue equal at a firm like this? Well, remember that the general rule for profit maximization is marginal cost equals marginal revenue. Well, marginal cost is equal to zero, and so the firm is going to want to set its output where marginal cost equals marginal revenue, or rather, where marginal revenue equals zero. If these two things are zero, they are equal to each other. Okay, so you can think of it in most of these graphs, we have like a red horizontal line that represents marginal cost, the marginal cost curve. And wherever the marginal revenue curve hits that marginal cost curve, that's where you have the level of output that maximizes profit. So imagine just taking that marginal cost curve and shifting it down farther and farther until the marginal cost curve is equal to zero, until it just exactly overlaps the x-axis. Well, that would tell you that you're going to want to set your output here, where marginal cost equals zero. Doesn't mean your price is going to be equal to zero, though. At that level of output, you plug that quantity into the demand curve, and the demand curve will return the profit maximizing price. Part B. All firms are trying to maximize their profits, which is, they point out, is profit is equal to total revenue minus total cost. The rule from Part A tells us that in the special case where marginal cost is zero, profit maximization is equivalent to which of the following statements? Maximize total revenue, minimize total cost, minimize average cost, or maximize average revenue. All right, well, you want to maximize your profit, which is maximizing the difference between your total revenues and your total costs. Ignore fixed costs for the moment, okay? Assume that your marginal costs are the only costs you have. Well, in that case, profit is just going to be equal to your total revenue minus your total costs of zero. And so that tells you that maximizing profit is just the same thing as maximizing your total revenue. Okay? Now, what if you allowed there to be positive fixed costs? Well, then you'd have profit is equal to total revenue minus fixed costs. But this number here, fixed costs, that doesn't change with the level of output. This doesn't change with the amount of revenue that you generate for yourself. So maybe that's $100,000 or $50,000 or whatever. It still is going to be the case that an extra dollar of revenue always increases your profits. So if you're subtracting a fixed number out of that total revenue, maximizing your total revenue is still going to maximize your profits. So the answer to Part B would be profit maximization is equal to maximize total revenue. And that brings us to thinking and problem solving. Problem 3. Now this one has a long preamble to it, which basically it talks about the fact that if a sports team hires an expensive new player or builds a new stadium, oftentimes you hear claims that ticket prices have to rise in order to cover the new higher cost. So in other words, you hear that they're justifying the increase in price by covering the costs, the new costs that they've added. Okay, so I'm not going to go farther into the preamble. Let's get straight into the questions. Part A says, as long as the sports team is profitable, will a mere rise in fixed costs raise the equilibrium ticket price, lower the equilibrium ticket price, or have no effect whatsoever on the equilibrium ticket price, and why? Okay, well, remember that a firm is going to set its price where marginal cost equals marginal revenue, right? You find that point, marginal cost equals marginal revenue right here. That sets the profit maximizing level of output, and then that also gives you the profit maximizing price. Now notice that we found that price without referring to the average total cost curve at all, okay? So and remember, the average total cost curve in this case is just your marginal cost per unit plus your average fixed costs. So the only difference between these two curves is the average fixed costs. This average total cost curve does not tell us where we need to set our output and therefore what price we should charge. So you could take this average total cost curve by increasing your fixed costs, you'd shift it upwards, but notice that that doesn't do anything to where marginal cost equals marginal revenue. Just shifting that black curve around doesn't do that. So no, just changing a firm's fixed cost is not going to affect the equilibrium ticket price. It'll have no effect whatsoever on that because it's not affecting the marginal cost or the marginal revenue of the decision-making process, okay? So that tells us that having to raise the price because your fixed costs have gone up, that can't explain why the prices actually go up, okay? Part B, in fact, it seems common in real life for ticket prices to rise after a team raises its fixed costs by building a fancy new stadium or hiring a superstar player. So part B is saying, look, there's no economic reason to believe that higher fixed costs increase the price, but we usually see the price go up after an increase in these fixed costs. So why would that be the case? It says, what's probably shifting to make this happen? What curve or curves are probably shifting to make this happen? Name both curves and state the direction of the shift. Okay, well, what's happening is in order for this to change, what must be happening is the marginal revenue curve is hitting the marginal cost curve at a different point than it was before, and that level of output is now generating a higher price than it was before. So let's think about why that might be. Suppose that you build a brand new stadium. Well, in that case, it's becoming more pleasant to come and watch your games than it was before with the older, more outmoded stadium. Or suppose you hire a star player. He makes the game more interesting to watch, and so people are going to enjoy the game more. In either of those two cases, the greater enjoyment from consuming the game is going to be reflected in a shift in the demand curve. Consumers are now willing to pay more than they used to be willing to pay because the amenities are better, or the games are going to be more entertaining, or you're going to be more likely to win a game. So this demand curve is going to shift up and to the right. So let's start by putting that onto this graph. Be something like this. Oops. There's our demand curve. Now the marginal revenue curve is also going to shift because the marginal revenue curve always starts at the same point as the demand curve does, and it falls at with twice the negative slope. So it's going to be something like this. And I'll give these each a prime. So D shifts up and to the right, demand shifts up and to the right from D to D prime. Consumers are now willing to pay more. Since the consumers are willing to pay higher prices, the marginal revenue curve is also going to shift from this original marginal revenue curve MR to MR prime. And now what happens? Well, with the new marginal revenue curve, that intersects the marginal cost curve at this point. It's going to give you a new level of output here. and that level of output plugged into this new higher demand curve will give you this higher price PM prime. Okay, so notice that I've left this average total cost curve exactly the same between these two shifts, because otherwise this graph is going to start looking messy, messier than it already does. But keep in mind, if you've been able to raise the price, meaning the average revenue per ticket from PM to PM prime, as long as your fixed costs or your average total cost curve shifts up by an amount less than that distance, well, then you're making more money, right? Because your revenue per ticket has gone up by more than your average total cost per ticket, and so profits have increased. Part C. So do sports teams spend a lot of money on superstars so that they can pass along the cost to fans? No. We already answered that. Why do they spend a lot on superstars according to monopoly theory? So that they can shift the demand curve. The increase in fixed cost is justified if you can shift that demand curve up by enough to more than cover that additional fixed cost. All right, so that is the answer to problem 3 in thinking and problem solving. And in the next video, we'll go back and give the answer to problem 2 in thinking and problem solving.